This is problem number 1 from section 3.7. In this problem it says use implicit differentiation to find dy over dx. And they give you an equation that's dx squared y plus 7x y squared equals 9. Now when do we use implicit differentiation? Well, this is starting to become slightly different than what we've been dealing with in the past. We use implicit differentiation anytime we have a function that's not written as y equals, let's just call it y equals 3x squared plus 4, where y is a function of x. Notice that we don't have y solved for here. We have y combined inside of this function with x squared and x. And so because they're combined in there, we can't just take the derivative like we normally do. We normally would say for y equals 3x squared plus 4, we'd say dy over dx equals, and we take the derivative of this and we get 6x, and the derivative of 4 would be 0, so we'd end up with our derivative straight away. But that's because the equation was written as y as a function of x. And when it's not written that way, we have to do this special type of differentiation called implicit differentiation. So here's how we do it. What we're going to do is we're going to take the derivative of each piece individually, but we're going to have to use the product rule on each piece. So we're going to start by saying that u is 8x squared. We're going to call v the y value here, and then I'm going to say that we're going to call this u2 as 7x, and then this is v2 as y squared. So let's start with u and v. So u is equal to 8x squared. Let's see, u prime, v is y, and v prime. And then over here I'm going to write u2, and then u2 prime. So u2 is 7x, and then v2 and v2 prime. So I've got y squared here. Now, because I'm taking the derivative, I'm trying to find dy over dx, the derivative of y with respect to x, essentially I'm supposed to only differentiate the x terms. So whenever I do the derivative on a y term, all I have to do is say that the derivative of y, I treat it the same way, derivative of y is 1, but I have to add in this dy over dx. So this is the derivative of y is 1, but that's times dy over dx essentially. And the same thing down here, we're going to do y squared, derivative of y squared, that's 2y, and then we add in the dy over dx at the end here. These I can differentiate just like I normally would, so 8x squared is 16x, and 7x is 7. So now I can use the product rule, finish it out with this piece, and then finish the product rule with this piece as well. So we're going to say that 16x times y, so we have 16xy, multiply the insides, plus 8x squared times dy over dx, so that's just going to be 8x squared dy over dx, right, when we multiply by 1 dy over dx. And then I'm going to take the derivative on this side, like this little piece here, so I have 7y squared, so plus 7y squared, and then plus, multiply the outside 7x and 2y dy over dx. So that's going to be 7x times 2y, that's 14xy. So 14xy, and then I have dy over dx at the end. And then finally, the derivative of 9 is 0. So that's just going to be equal to 0. Now you'll notice that I've differentiated this function, but I don't know what the derivative is because I don't have dy over dx by itself. So what I need to do is I need to rearrange this so that I have dy over dx on the left side like I do here, by itself, saying that the derivative with y with respect to x equals some function. So let's go ahead and move 16xy to the other side, move the 7y squared, and move the 14xy over. So I'd end up with 8x squared dy over dx plus 14xy dy over dx is going to equal, when I subtract these over, I get negative 16xy minus 7y squared, and then yeah, that's it. That's the only two terms that I have on the right side. So now I'm going to factor out dy over dx. When I factor out dy over dx, I end up with dy over dx. And inside the parentheses, I have 8x squared plus 14xy equals negative 16xy minus 7y squared. So now I gotta get dy over dx by itself, divide by the 8x squared plus 14xy. And so I divide on each side. And I end up with my derivative of y with respect to x is equal to negative 16xy minus 7y squared all over 8x squared plus 14xy. Now remember, this is going to give you, a derivative is going to give you the slope of this line at any point on that line. So this is our derivative here using implicit differentiation.